Learning Outcome 9.4b. Find possible ROCs given transform functions. In Learning Outcome 9.4, Example 2, you are given an x of t equal to 3 e to the negative 4t u of t minus 2 e to the negative t u of negative t. From that, we had the x of s equal to 3 over s plus 4 plus 2 over s plus 1. From the first part, we know that the real part of s is bigger than negative 4, and from the second part, we know the real part of s is less than negative 1. So the ROC that applies to this time function has the real part between negative 4 and 1. Now let's take this problem and look at it the other direction. If I gave you the x of s, which was 3 over s plus 4 plus 2 over s plus 1, what is the ROC? Now you don't have the time function. We don't know which inverse to use from the table. We have options. Also note that this x of s, we quite often write it, combining those two terms, to give you 5s plus 11, divided by s squared plus 5s plus 4. This shows you that there is a 0 present, which we didn't talk about before, because it does not affect the choice of ROCs. So let's look at this term by term. The first term, 3 over s plus 4, can have an ROC bigger than negative 4 or less than negative 4. The second term can have an ROC bigger than negative 1 or real part of s less than negative 1. We have two options for each term. Therefore, we have a total of 4 choices to consider for the final ROC. So let's look at them in a grid with one pole on the top and the other pole on the side, 2 by 2 grid. We have 4 choices. The real part of s can be greater than negative 1 and the real part of s greater than negative 4. The real part of s can be greater than negative 1 while the real part of s is less than negative 4. The real part of s can be less than negative 1 while the real part of s is bigger than negative 4. Or the real part of s can be less than negative 1 while the real part of s is less than negative 4. These merge to say that we've got the real part of s less than negative 4, real part of s between negative 4 and negative 1, and real part of s bigger than negative 1. The other option has an empty set, and therefore we don't consider that one. If we have 2 poles, we have 3 options for what our ROC can be if we consider only non-empty ROCs. Let's consider another example. Now we have complex poles located at negative 1 plus 2j or negative 1 minus 2j. We still have the options of our ROCs being greater than or less than negative 4 or real part of s greater than or less than negative 1. And we still have 3 possible ROCs present. I drew another example of a 0. Again, the zeros do not affect your ROC.